one if you guys want to look at one of those in that regard. So in this one, guys, this looks confusing. Uh-oh. Those weren't too bad. Those weren't too bad. But this one doesn't look that much fun. So the way that I remember it is, wow, hey, that whole idea of Mr. McLogan giving a warm-up was all preparing us for this. So instead of thinking of signs, just think of x's, guys. Forget about the signs for a second. And just say, all right, let me step back, forget about trig for a second, and just see, can I factor this? And this should be factorable if I did the math in my head correctly. So this should be a +2, and this should be a -1. No, that should be a, sorry, +1, right? 2 times 1 is 2x. X times 1 is -1x, so that gives you x. -1 times 1 is x, so that's good, right? So now all I do is I replace them with x's so I could factor them, because I'm more comfortable factoring with x's than signs, which I'm assuming the majority of you guys would feel the same. And then I just replace the signs back in there. Thetas, sorry. Do you guys see what I did? So I just replaced them back. So I did the algebra with the x's instead of doing them with the signs. And now I can apply the zero product property. And then therefore, this one, sine of theta is equal to +1/2 this time. And sine of theta is equal to -1. So what angles is sine of theta equal to 1/2? Thinking of the unit circle, that's going to be at so thinking of the pi/6 and 5 pi/6. So I'll use my solution set here. You guys see how fast I'm using the unit circle now? That's what I'm saying. Like if you're still slow in the unit circle, we got to get you up to speed quickly, because we start using the unit circle very quickly. And then the point on the unit circle, it's over there where sine is equal to -1. It's on that one over there. What's that angle? 3 pi/2. Right? And you can't do -pi/2 because it's not in the quadrant. OK? Because over here, 3 pi/2, the y coordinate is -1. Sine is equal to -1.